Okay, here we are, section 9.3, hypothesis test for population mean having the standard deviation known. Test hypothesis about a mean using a p-value method, using a critical value method, and we're going to take a look at using the p-value method. We'll begin the section with an example. Suppose that a recent study, 76 subjects were placed on a low-fat diet. After 12 months, their sample mean of loss was 2.2 kilograms with a sample standard deviation of 6.1 kilograms. Can we conclude that the weight loss is greater than 0? Now, if we knew the population standard deviation, excuse me, we would be able to compute the z-score and use this test statistics to perform the hypothesis test. But in this example, as usually the case, we don't know the population standard deviation. So to proceed, we have to replace the population standard deviation with the sample standard deviation and use the t-test statistic instead. So when the null hypothesis is true, the t-statistic has the student's distribution with n-1 degrees of freedom. Assumptions. We have to have a simple random sample and that the sample is large or the population is approximately normal. Since we have a simple random sample and the sample size is large, we can continue with the test. The issue is whether or not the mean loss or mu is greater than 0. So our null hypothesis is that it's equal to 0. And our alternate is that it is greater than 0. Here's our t-test statistic. We're going to put 2.2 minus 0 over our 6.1 divided by our square root of 76, and we get 3.114 when the null hypothesis is true. The test statistic t has a student's distribution of 75 degrees of freedom. This is a right-tailed test, so the p-value is the area under the student's t-curve to the right of 3.144. So if we use technology, we can find the exact p-value to be 0.0012, and since p is less than 0.05, we reject the null hypothesis at the 0.5 level. So we can conclude that the mean weight loss of people who adhered to the diet for 12 months is in fact greater than 0. The p-value of this test statistic is the probability, assuming that the null is true, of observing a value for a test statistic that disagrees with strongly as or more strongly with the null hypothesis than the value actually observed. The p-value is an area under the student's t-curve with n-1 degrees of freedom. The area is in the left tail, the right tail, and both tails, depending on the type of test. So the left tail means that the p-value is the area to the left of t. The right tail is the p-value to the area of the right of t, and the p-value in a two-tailed test would be the sum of the area of the left and the right. So when using the table, we cannot find the p-value exactly. Instead, we can only specifically that p is in between two values. In the last example, there are 75 degrees of freedom. We therefore must use the next smallest number, which is 60. So 75 is not in here. The next smallest number is 60. Okay, so you don't go to the closest, you go to the next smallest. Now look across the row for the two numbers that bracket the observed 3.11. Here we have these two, right in between these two. The upper tail probabilities are 0.0025 for 2.915 and 0.001 for 3.232. The p-value must therefore be between these two values. So we can conclude that the p-value is in fact small enough to reject the null hypothesis at the 0.05 level of significance. Now, if the alternate hypothesis H1 were the mean is not equal to 0, the p-value would be the sum of the two tails. If using table A3, we can only specify that p is in between two values. We know from table A3 that the area in one tail begins in this. Therefore, the area in both tails have to be that. So we're going to take 2 times this and then 2 times the second one. That will equal 0.05. Now let's go back. Okay, so again, just want to be sure that you see that if it's a two-tail, it's still going to be statistically significant here because we are still going to be smaller than 0.05. Okay, now we can go on. Generic drugs are lower cost substitutes for brand names. Before a generic drug can be sold in the United States, it has to be tested to found and perform equivalently to the brand name product. The U.S. Food and Drug Administration is now supervising the testing of new generic antifungal ointment. The brand name ointment is known to deliver a mean of 3.5 micrograms of active ingredient to each square centimeter of skin. As a part of the testing, 7 subjects applied the ointment. 6 hours later, the amount of drug that has been absorbed into the skin is measured. The amounts in micrograms are as follows. How strong is the evidence that the mean amount absorbed differs from 3.5 micrograms? Use the alpha at the 0.01 level of significance. So we're being really picky here because we're picking a very small level of significance. First, we're going to check the assumptions. We can see that it's small, but it looks approximately normal. So we're okay with that. There's no evidence of skewness or outliers, so we can proceed. So the null hypothesis is that the mean will be 3.5 versus the alternate hypothesis where it is not going to be equal to 3.5. When we compute the sample mean and the sample standard deviation, the values are 2.9429 with a standard deviation of 0.4995. Put that in to get your t-test statistic, and the number of degrees of freedom is 6. The alternate is two-tailed, so the p-value is the sum of the left of the observed t-statistic and the right. Using the two values in a row correspond to 6 degrees of freedom. The area to the right of 2.447 is 0.25, and the area to the left, it should say the left, another mistake, is 3.143. So therefore the area in the right tail is between 0.01 and 0.025. So the p-value is twice the area in the right tail. So we can conclude that the p-value is between 0.02 and 0.05. Now keep in mind, we were looking at 0.01. The p-value is small enough to give us doubt about the truth of the null hypothesis. However, we're not going to reject it because it's not, it is bigger than 0.01. So somebody might read this and they might want to go back and take a look at this same study and change the confidence level to be 0.05. And if they did that, then we would be able to reject it. But as it is right now, there's not enough evidence to conclude that the mean amount of the drug absorbed differs by 3.5 micrograms. Test hypothesis about the mean using the p-value method. In the beginning of this section, we suppose that a recent medical study, 76 students were placed on the low-fat diet, and after 12 months, their sample mean loss was 2.2 kilograms with a standard deviation of 6.1 kilograms. Can we conclude that the mean weight loss is greater than 0? Now, if we knew the population standard deviation, we'd be able to compute the z-score, but once again, we can't. So we're going to take a look at the t-statistic instead with n minus 1 degrees of freedom. The assumptions for performing the hypothesis test: we have a simple random sample and it is larger than 30. Since we have a simple random sample and the sample is large, we may proceed with the test. The issue is whether or not the mean loss, mu, is greater than 0. So here we have our t-statistic. When the null hypothesis is true, the test statistic has the student's t-distribution 75 degrees of freedom. This is a right-tailed test, so the p-value under the student's t-curve to the right of t equals 3.114. Using technology, we find exactly the p-value to be 0.012. We reject the null hypothesis at this level, so we can conclude that the weight loss of people adhered to the diet is greater than 0. Now we want to do that on our TI-84. We can go through, we hit the t-test. We want to put in either the data or the stats. We have the medical study again. Taking a look at these values, we're going to substitute them in. Our mean mu is 0. Our sample mean is 2.2. Our standard deviation is 6.1. Our number of people is 76. We are looking at whether it's greater than the null hypothesis. Oh, let me back up one. Okay, so here are our values underneath here. Since the p-value is 0.001 and our p-value is smaller than 0.05, we will in fact reject the null hypothesis and conclude that the mean weight loss of people who adhere to the diet for 12 months is in fact greater than 0. Okay, we already looked at this one with our brand name drugs, and we saw that it is not skewed. Now looking at putting it into the calculator, we want to put our values into the list. So that is our data. So when we go to test, z-test, and then over here we're going to say data instead of stats because we placed our data in list 1. Put in the information that we do have, and we are looking at not equal to the population mean that we had before. So that's our two-tailed test. Here are the values. Here's our p-value. Here's our mean. Here's our standard deviation. And since there's not enough evidence to conclude that the mean amount of drug absorbed differs from 3.5, then the mean might be equal to 3.5 micrograms. We're not saying that it's not. We're saying it might be. And we're not saying it is either. We're saying it might be. Okay, test hypothesis about using the mean and the critical value method. Here we have the left-tailed and the right-tailed and the two-tailed again. So similar from before, we have t is less than or equal to negative t alpha. For the right-tailed, t alpha is greater than or equal to, or t is greater than or equal to t alpha. And then for the two-tailed test, you're going to look at each side. So you're going to have t is greater than t alpha over 2, or t is less than negative t alpha over 2. So we're going to look at the computer software vendor claiming that a new version of their operating system will crash less than 6 times per year on average. Whew, 6 times per year. That's a lot. It's like every other month. So a system administrator installs the operating system on a random sample of 41 computers. At the end of the year, the sample mean of crashes is 7.1 with a standard deviation of 3.6. Can you conclude that the vendor's claim is false? We're going to use a 0.05 significance level. We checked the assumptions, so we're satisfied. So we're going to put the null hypothesis as equal to 6, and the alternate is greater than 6. The significant level is 0.05. The numbers of degrees of freedom is 40. And since this is a right-tailed test, the critical value is going to be 1.684. So we have a sample mean of 7.1. We have the null hypothesis of 6. We have the sample standard deviation of 3.6. And the number is 41. Because this is a right-tailed test, we're going to reject the null hypothesis if t is greater than or equal to t alpha. Since t is 1.957 and t alpha is equal to 1.684, we're going to reject the null hypothesis and conclude that the mean number of crashes is, in fact, greater than 6 per year. So here we go. The assumptions for the hypothesis test for when the mean and the standard deviation is unknown, how to perform the hypothesis test for when they are unknown using the p-value, how to estimate a p-value from a table for one-tailed and two-tailed tests, and how to perform hypothesis tests for the mean and the standard deviation is unknown using the critical value method. Okay, so there we go, and we'll see you next time for section 9.4.